let's look at the half-angle identities. So consider the following half-angle identities. I have sine of alpha over 2 equals plus or minus the square root of 1 minus cosine alpha all over 2. Cosine of alpha over 2 is plus or minus square root of 1 plus cosine of alpha all over 2. And tangent of alpha over 2 equals plus or minus the square root of the quantity 1 minus cosine alpha over 1 plus cosine alpha. And so you'll notice that I have plus or minus on each of these expressions here on the right for these identities. And so, these still need to act like a function. So I can only have one value here on the right side. So that means I need to pick plus or minus each time I am using one of these. And how do I pick plus or minus? So I pick either the positive or negative sign based on the quadrant of the given angle. So I'll write that. I'm going to choose positive or negative based on the quadrant of the given angle. And so let's be more specific, alpha over 2. Okay, so let's look at an example. Determine the value of sine of 22.5 degrees. Well, 22.5 degrees is going to act like alpha over 2. Well, alpha over 2 lives in quadrant 1, and sine is positive in quadrant 1. So I am going to pick the positive value. Okay, so what does that mean? Well, if 22.5 degrees, if I'm going to kind of think of that as playing the role of alpha over 2, this tells me that alpha is just 45 degrees. Okay, so let's see how I want to use this identity. So I'm going to have sine of 22.5 degrees. 22.5 degrees is an angle that's not on my unit circle, so I want to be able to use one of these expressions to determine what the value is going to be. And so it says you don't need to know anything about 22.5 degrees, right, which is really kind of like half of an angle, as long as you know something about the full angle, which is 45 degrees, and I do. So I'm going to say sine of 22.5 degrees is plus, because I'm picking the plus on this one, okay, the square root of 1 minus the cosine of, okay, well, notice that now I need the full angle, so I need 45 degrees, so cosine of 45 degrees, okay, all over 2. So what does that give me? Well, that gives me the square root of 1 minus root 2 over 2, all over 2. And then inside this little square root here, I can kind of extend it and look at that fraction in there and multiply the top and the bottom by 2. So from here, I get the square root of 2 minus root 2 in the numerator, and then the denominator is just 4. But I do notice that 4 is a perfect square, so I can apply the square root to the numerator and denominator separately and get the square root of 2 minus root 2 all over, well, the square root of 4 is just 2. Then I can just leave it like that. So what I did is I started with something that I did not know, right? Sine of 22.5 degrees, but I kind of thought of 22.5 degrees as half of some angle, solved for that angle and said, that's the angle that I know something about, and then used this half angle identity in order to determine the value of sine of 22.5 degrees. Example. Determine the exact values of the following expressions given that sine of alpha is negative root 3 over 3 and alpha is in between 3 pi over 2 and 2 pi. So we always want to do a nice drawing here. That usually gets us most of what we need. If alpha is in between 3 pi over 2 and 2 pi, then I need to be in quadrant 4. Okay, so this is telling me I'm in quadrant 4. And it's telling me that sine of alpha is negative root 3 over 3. So just like what we've done before, I'm going to write that as negative root 3 over 3 because 3 is going to play the role of r, and negative root 3 will play the role of y. And this is just for our generalized trigonometric definitions. And so Then I'm going to draw some circle with radius 3, where in quadrant 4 I have some angle, right, where the terminal side intersects, say like here. Okay, so here's my angle, and I'm going to call that alpha. And then I have some point on that terminal side that intersects this circle with radius 3. Okay, so that's my r. And then I have some x and some y. The y value I've determined is negative root 3, and that makes sense because I'm in quadrant 4. And now I need to determine the x value. I can determine the x value by drawing in a right triangle. Okay, and then again, I usually just kind of draw that triangle out somewhere else so that I can kind of see what I'm after. Okay, so let's draw in the lengths. I have 3 for the hypotenuse. This is a right angle. The angle here I actually do know something about because it is the reference angle for alpha. Okay, y is negative root 3. Okay, and sorry, these kind of look like they're fractions over here, but this is just x is representing that value and y represents this value. Okay, so that means the vertical length of this triangle is going to be opposite of negative root 3, which is just 3. And then let's see, which is negative root 3. And then I'm going to be solving for the length of this side, and we can call that anything we want. I'll call it b. Okay, so I'm going to have, 3 squared is b squared plus root 3 squared. So I have 9 equals b squared plus 3. B squared is 6. So b is just root 6 because it's a length. And then I decide this length tells me how far I need to travel from the origin, right, to get, I'm going out this much on my way to get to this point. Since I travel to the right, I'm going to call my x value positive root 6. Okay, so now I have an x value, I have a y value, and I have an r value. But sometimes they kind of get lost, so you can always like rewrite them. You're like, okay, what did I find? I found that x was root 6, I found y was negative root 3, and r was 3. Okay, so now I can find the values of these two expressions. I have sine of alpha over 2 and cosine of alpha over 2. So what is sine of alpha over 2? Well, this is where you gotta kind of go up and find what you were doing. And I need, I need this thing right here. So, okay. All right, so I'm just gonna kind of keep this down here so I can look at it. So if I need sine of alpha over 2, well, first I need to decide where alpha over 2 lives, right? So I need to determine the quadrant for alpha over 2. So I want to determine the quadrant for alpha over 2. So first what I'm going to do is say, well, I know that alpha is between 2 pi and 3 pi over 2. And then what I'm going to do is multiply each of these by 1/2 and then see what I get. Well, this becomes 3 pi over 4 less than alpha over 2 less than pi. Well, where would that have to be? Well, that has to be, between 3 pi over 4 and pi. This is in quadrant 2. Okay, so that has to live in quadrant 2. And so in quadrant 2, sine values are positive. So when I am doing this sine of alpha over 2, I'm going to pick the positive one. So I get sine of alpha over 2 is positive the square root of 1 minus cosine alpha. Well, cosine alpha is just x over r, so root 6 over 3 all over 2. And then to simplify, inside that square root, right, I'm just working on this little fraction in there, doing regular fraction moves, in this case just multiplying it by 3 over 3 to get rid of the little mini 3 in the numerator. And so I get the square root of 3 minus root 6 all over 6. I'll just leave it like that. All right, so knowing what I just did in this example for part B, cosine of alpha over 2, I know that since alpha over 2 is in quadrant 2, cosine should be negative. And that's just because we are in quadrant 2. So when I pick cosine of alpha over 2 and I start writing that out, I need to pick the negative version. So let's go back up. How does this compare to the sine formula? It just has a plus where the other one has a minus. So you can probably remember that. Okay. So I'm picking the negative version. I'm taking the square root, and I need 1 plus cosine alpha all over 2 minus the square root of 1 plus. Okay, so now I'm adding, and cosine was root 6 over 3, and then all over 2. And so then again, I just take that multiplying by 3 over 3 within there, and I get negative square root. So again, the 3 just multiplies in, and when that happens, the numerator becomes 3 plus root 6, so I get rid of that over 3 piece, and then the 3 multiplying by the 2 in the denominator gives me 6, and make sure your square root extends over that whole fraction.